Welcome to Ask and Learn.
In this problem, we have another bent bar that's supported at three different points, and there are two applied loads now. One of those applied loads is acting here, and they've labeled it F1, so I called mine F1 to avoid confusion. It is in the YZ plane as a magnitude F1 and is given in this direction by this unit vector. And its position is minus 5 feet in the y direction and 5 feet in the z direction. Now, the first constraint, which is labeled point A, is it's free. The pipe or the bar is free to slide in the z direction, so we only have components in the x and y, and it is located at minus 4 feet in the y and minus 5 feet in the y and 4 feet in the z. At the next constraint force, which is at point B in the figure, the bar is free to slide in the y direction, so we have x and z components, and it is just minus 3 feet in the y direction. Then we have an applied load, and it has a magnitude, and we're given the direction again kind of in spherical coordinates, so using two angles. And those two angles are phi and psi, and we're given those. And again, you can kind of project it onto the z-axis, and then project things onto the in the xy plane, and then project it onto the x-axis, and then project onto the y-axis. And that is where our origin is, or the origin given in the book, which I've just kind of used for my origin. And then finally, we have another constraint. And the rod is free to slide in the x direction in this case, so we have a y and a z component. And this constraint is located at minus 5 feet in the x direction. So if we sum forces and sum moments, we have 5 different loads here. We have, let's see here, we have, this is known. We have 1, 2, 3, 4, 5, 6 unknowns, because this is known and all these angles are given. So 6 equations from here, and we have 6 unknowns, and we can just crank through the algebra, doing it carefully, and we get that F2, the reaction at the support at point A in the figure is 633 pounds in the x direction and minus 141 pounds in the y direction. The force, the constraint at point B in the figure is minus 721 pounds in the x direction and 895 pounds in the z direction. And finally, the force, the constraint force at point C in the figure is 200 pounds in the y direction and minus 506 pounds in the z direction. So it's a little hard. Again, these are kind of right magnitude. This force had a magnitude of 300 pounds, and this was 250 pounds. So these are obviously in the right ballpark. It's a little hard to figure out what exactly how these supports are really carrying the loads. Intuition, when you have geometry kind of like this complicated, your intuition starts to kind of break down. And you can, again, you can see that basically constraints at B and C need to carry all of the Z load. The constraints at, let's see here, at A and C need to carry all of the Y load. And the constraints at A and B need to carry all of the X load. So you can just make, basically that's saying that the sum of the forces must be 0. So there's your answer.